Hello, students. So here is the solution to your final, the quiz 6. That's not basically 3. So this is a means of preparation for your tomorrow's test. So in the tomorrow's test, everything will be included that we have learned till yesterday homework. Okay. So apart from this, parallel lines, perpendicular lines, and to decide about the lines and proofs of the special quadrilaterals, those will be included. So just to have a solution, they said sum of the measures of the interior angles. So you know the formula for that is n minus 2, 180. N is the number of sides gone. So 27 minus 2, 180. Once you multiply, you get 4050. So B is the choice. Once you come over here, DCE. So let's see who is DCE. So if you look at it, your DCE is this guy. So who is this? This is the angle who is a linear pair with this angle, which is 7x minus 2. So if we can get 7x minus 2, the 7x minus 2 and DCE are supplementary. So if we can get the value of this red portion, we can subtract that from 180 and to get this DCE. So now what we need to know? We need to know the value of x to get this 7x minus 2, right? So how do we get x? We know we are given with the exteriors of a polygon, which is a triangle over here, which are 9x minus 31. So sum of this exterior of any polygon is, and any number of sides will be 360. So we can say 9x minus 31, 7x minus 2, 4x plus 33, which is this, is 360. Once you solve, you get x is 18. So now plug in the value of x 18 over here. So you get 124. Now your job, this whole thing is 180. This guy is 126. You subtract 126 from 180, you get 56. So that's your answer. And which of the following quadrilaterals always have diagonals that are congruent? A rectangle, if of this size, they have a congruent diagonals, okay? A parallelogram do not have that. A rhombi do not have that. They're different. A square, all the sides are congruent and the diagonals are also congruent. Isosceles trapezoid. So two of the non-parallel ones are congruent. So their diagonals also become congruent. So it's rectangles, squares, and isosceles trapezoid. And in number 4, they say AB is a parallelogram. So in the parallelogram, whatever the properties a parallelogram has, it should follow them. And now they say AB is extended. So this is the parallelogram we have. This AB is extended to E and B to E, and C is drawn. This CE is drawn, okay? And now they say C is congruent to B. That means this guy is congruent to this guy. What does it mean? It means this angle is congruent to this angle. If it is X, this will be X. Now they ask for what is the measure of this E. What is that? So if we can get an X, so we can say X plus this measure of E, 3 angles of a triangle, they will be 180 degree. So our job is to get X. How can we get that? We are given that D is 118. This D is 118. What does it mean? This guy is 118. Okay. So X is 180 minus 118 means 62. All right. So this is 62. This is 62. So your X is 62. You can say 62 plus this X is 62 plus the measure of E, all right? So that is 180. So you see this gives you 4 and 12, 126, and measure of E, 180. So you can get measure of E is 180 minus 124, 56, okay? And someone can think in another way. if if you look at it, how does it look? This triangle, this is the exterior. So you can think something like that. You have a 62 here. You don't know this guy, so let it be y, and you know this is 118. Okay, so you can add y plus 62 because sum of these two non-adjacent interior equals to the exterior, and solve for y. You will still get 56. Okay, this will still be 56. So that's your choice. Parallelogram is always a rectangle if a parallelogram is like this. So it will become a rectangle when all the four sides, you bring this point here, bring this point here, okay? So this will be a rectangle. So what happens? The diagonals are congruent. These diagonals become congruent to each other. So this should be the answer. And now over here, parallelogram ABCD shown below, bisectors of ABC. ABC, bisector. So this guy is congruent. If it is X, this is X. And DCB. So DCB, that means this guy and this guy is congruent. They are bisecting. So if this guy is Y, this guy has to be Y. All right. So now they say they meet at the point E. Now A is 70. So if this guy is 70, this is a parallelogram. So opposite side has to be 70. So Y plus Y is 70 means 2Y is 70. That means each of the angle over here, Y is 35. So you can say this guy is 35. Now, if you know this is 70, this is a, you see these are the parallelograms. So parallel side, two lines parallel, a transversal. So they are supplementary because they are same side interior or consecutive angle. So if it is 70, this whole thing is 110. You subtract 70 from 180, you get this. So what does it mean? It means 2x equals 110. So once you divide, bisectors are 55. Okay, so you can tell that x is 55. So if this is 55, this is 35, and this guy is how much? If it is, let's say, let me use z. Okay, so this is a triangle where sum of the three angles are 180 degree. So you can say 55 plus 35 plus your z, which you don't know, is 180. So z is 5, 5, 10, 1 remains in hand, so 90. So easily you can see that your z is 90. Am I right? Because you can subtract 90 from both sides, so your z becomes 90. So you'll have to show your work for this kind of works, and you say answer 90, what is measure BC. So you say the measure of angle BEC equals 90 degree. All right. Okay. So now for this one, there is something I forgot to change this one. This is basically C is 37, RO is not 65, that's 85. Okay. So this is a parallelogram. So if it is 37, this has to be 37. And we ask you to find out KSO. KSO. So look at it. How does it look that? This is a triangle where this is the exterior. So sum of these two non-adjacent angles, 85 and 37, equals this guy. So measure of KSO. So this is 7, 5, 12. One image in hand, 4 and 8, 22. So that's measure of KSO. Okay, that's it. Now let's look at this. If you say JM is 27, so JM 27, and it's a parallelogram. I mentioned it during the test, though I should have written it. So ML is 16. If JM is 27, the scale is also 27. ML is 16, this is 16, means opposite sides are congruent in a parallelogram, okay? So that guy is also 16. And then JL is 47, JL 46. So half of it, they bisect. Diagonals bisect each other. This guy congruent. So JN is 23, this guy is also 23. And then NK is 15. So NK. So this is becoming very small. Let me make it a little light, longer. I can hold it and write at the same time. So this is 15. This guy has to be 15. All right, because they are congruent, bisecting each other. KLM 48. Okay, let's go to that later, because this place will become clumsy. So let's write what is KL. KL is 27. Most of you have got them right. JK is 16, because this is it. And MK is MK. So 15 plus 15. So that's 30. And NL is 23. So it's 23. All right. And JKL. Okay, JKL. So let's come up. Forget these things. Now let's find the value of the angles. They said KLM is 48. KLM. So this guy is, whole thing is 48. That means this guy is also 48. This is the opposite angles. JKM is 78. JKM up to this is 78. All right. And MJL is 22. This guy is 22. Okay. Let me draw it a little separately so that it looks bigger and nice. Okay, so this is something like this. So let's say JKL. So they want JKL. Let me write that JKL M and N. Now the first thing is we are given with 78 is JKM. This is 78. Okay, and we have this KLM. This is 48. Now if we need to find out this JKL, which is JKL, this whole thing, is quite easy, because you see the way I have decided about this guy. If 70, this 110, because they are consecutive angles. Exactly for the same reason, you can say this guy is 48. So this guy is 48 plus measure of JKL. This whole angle should be 180 degree. So you subtract 48 from both sides. So your measure of JKL equals to 2, 3, that's 48. Am I right? JKM is 78. Okay. KLM 48. Okay. So from 180, if you subtract 48, you get 2. 1 is there. It's 5. So you have a 3 and you have a 1. 132. So this guy is 132. Means this whole thing. Then they say KLJ. KLJ. Now look at it. Who is KLJ? KLJ is KLJ is this guy. Now, we are given with another angle. MJL is 22. MJL, this guy is 22. Now you see this guy and this guy is parallel. If you separate this guy, this green line, they're parallel, and this is the transversal. So can't you tell this guy and this guy is congruent, because they're alternate angles. All right. So we can say this guy is also 22 degree. So KLJ is 22 degree. Then KMJ. So this guy. Again, we can say, let me use another color. Let's say this. Okay. So KMJ, KMJ, this angle. So now you see here, uh, uh, this guy and this guy is parallel line and this guy is transversal. All right, so we can tell this angle, if it is x, this is also x. All right, so this whole thing is 132. So if I subtract 78, I get this. So 132 minus 78 gives me how much? 4, 8, so 5, 54, right? If my calculation is right, I think it's right. So this is 54, this is also 54. So let me erase that and write nicely. 54, okay? So JMK or KMJ, this guy is 54. All right, and KJL, KJL means this angle. Okay, so now if you think, you can think in many ways. One is, if this one is 48, easiest way is to, this one is 48, this guy is 48. So 22 plus, let's say, is y, is 48. So you can say y plus 22 equals 48. So you can say y equals 48 minus 22. So it's 6. And this is 2, 26 degree. That's it. Okay. So you'll have to be a little critical in thinking. Okay. So mostly work with the parallel lines, perpendicular line, and proof from the region problem. So good luck and have a great weekend. Thank you.